Welcome to the deep dive. So picture this. It is your very first day working on an offshore oil rig.
Oh, high stakes right out of the gate.
Right. Very high stakes. The environment is loud. It's, incredibly intimidating. And one wrong turn of a high pressure valve could literally cost the company millions of dollars, or, much worse.
Yeah, absolutely.
So you are highly motivated, probably slightly terrified, and you're ready to learn. Your boss walks in, looks you dead in the eye, and hands you this dusty 300-page PDF document that looks like it was formatted on a typewriter in 1998.
Oh, the dreaded binder. We've all seen it.
The binder of doom. He pats you on the shoulder, says, "Good luck, study up," and just walks out. And today we are looking at a stack of documents from April 2026 that promise to make that terrifying, incredibly common scenario completely obsolete.
Well, it's an incredibly vivid scenario, but it really gets to the absolute core of what we are unpacking today. We're looking at a major announcement, plus some detailed white paper excerpts regarding a platform called Genesis 3.0.
Right, from EON Reality.
Exactly. Released by EON Reality and EON AI Ventures. And the fundamental theme here isn't just, a software update. We are talking about a structural failure in how human knowledge is transferred.
Which is huge.
It is. Yeah. Because knowledge and training, no matter how vital they are to an organization's survival, they're only as good as our ability to actually distribute them to the people doing the work. If the delivery mechanism is a massive, impenetrable binder, that knowledge is essentially trapped.
And as the source material points out, trapping that knowledge creates this multi-million-dollar paradox. Let's unpack the sheer scale of the problem before we look at the solution, because the text hits us with some jarring statistics right out of the gate.
The numbers are wild.
They really are. We know objectively that extended reality, or XR, works for training. The document points out that VR-based soft skills training boasts a massive 275% return on investment.
Right.
275%. That is an enormous leap in efficiency.
Yeah, but the paradox lies in the sheer gap between that proven massive value and actual real-world adoption. Because despite that incredible ROI, the data shows that fewer than 8% of enterprises actually deploy extended reality training at any kind of scale.
8%? That's nothing.
It's tiny. And even more alarming, less than 1% of existing standard operating procedures. So, those vital safety protocols, those maintenance manuals, less than 1% have been converted into immersive formats.
Less than 1%. When I read that, it almost felt unbelievable given how much we talk about the future of work. It's like a company buying a fleet of state-of-the-art million-dollar sports cars for their employees.
Okay, I like this analogy.
Right, so they park them in the corporate lot, hand out the keys, but then they outright refuse to build any roads.
Yeah, exactly.
The hardware, the sleek new VR headsets, the augmented reality glasses, the physical cars in this analogy, they're sitting right there. But there's absolutely nothing to drive on, so the natural question is, why on earth aren't these companies building the roads?
Well, the answer comes down to resources, time, and just the sheer complexity of the old way of doing things. The bottleneck isn't the hardware anymore. We have great headsets.
For sure.
The bottleneck is the content creation pipeline. According to the white paper we're analyzing, building just one single traditional XR training module is a monumental, incredibly friction-heavy undertaking. Historically, it takes anywhere from 6 to 12 weeks to complete a single simulation.
Wow.
And the cost ranges between $50,000 and $200,000.
Okay, just to put a fine point on that, that is up to $250,000 for one single scenario.
Just one.
If you run a logistics facility and you have 50 different safety protocols to teach, you cannot drop $10 million and wait 3 years to get your training program up and running.
Precisely. Because in the traditional model, you aren't just typing up a Word document. To build immersive training, you are effectively running a high-end video game studio. You need highly specialized talent. You need 3D artists to sculpt and texture the environment, software developers to code the physics and interactions.
Which is not cheap.
Not at all. And you need instructional designers to make sure the whole thing is actually educational and not just, a toy. And there's a massive global talent shortage in those specific fields right now.
Which explains why you, the person listening to this deep dive right now, probably haven't experienced a high-end photorealistic VR training simulation at your own job yet.
Yeah.
I mean, the barrier to entry has simply been too high for most companies to justify the investment.
Exactly.
And the companies are feeling the pain of this. They are desperate to upskill their workforce for the complexities of an AI-driven economy, but they are entirely locked out of the tools that would let them do it efficiently.
And this is exactly where Genesis 3.0 enters the picture. The documents outline what they are calling a structural innovation. It's really a complete paradigm shift in how this content is generated.
So how does it actually work?
Well, the core promise of Genesis 3.0 is completely dismantling that multi-month, $200,000 authoring process and replacing it with an 11-step plain English AI workflow.
Okay, so they're essentially moving the capability away from the specialized, highly paid technical teams and handing the keys directly to the subject matter experts.
Yes.
But I have to stop here because this is where I was genuinely skeptical when I first read the announcement.
Really? How so?
Well, I'm trying to picture someone who has spent 30 years intimately learning a physical trade. Let's say our expert is an aerospace mechanic who knows every single inch of a Boeing engine,
Okay.
but they have never written a single line of code in their entire life. How can that person suddenly build a fully functioning, interactive, photorealistic VR simulation? I need you to walk me through the mechanics of this because it honestly sounds like magic.
It really does sound like magic until you break down what they call the create phase. That covers the first 7 of those 11 steps in the Genesis 3.0 workflow. The system essentially acts as an ultra-competent technical middleman. It starts with the foundation, the 3D object itself. The mechanic doesn't have to sculpt a jet engine from scratch using complex 3D modeling software. They can simply import a CAD file, the engineering blueprint, that the company already owned.
Oh, gotcha. So they already have the files.
Right. And if they don't have a CAD file, they can use an EON 3D object scanner to scan the real-world piece of equipment with a mobile device. Or they can just pull from a massive pre-existing cloud library of assets.
Okay, so the visual asset is handled, but having a static 3D model of an engine sitting in a blank white digital void isn't a training module. It needs context.
Yeah, and that is where an AI component called WorldLab takes over. WorldLab automatically generates the required photorealistic environment around that imported object. So it builds the hangar, the lighting, the tools on the workbench.
That's incredible.
But to address your skepticism about how the mechanic actually programs the training, this is the most critical mechanism. The system automatically parses the written standard operating procedures. It literally reads the text of that dusty 300-page manual.
Wait, hold on. This is where I need to push back.
Okay, go for it.
A manual simply says something like, tighten the primary pressure valve to 40 pounds of torque. How does an AI read a string of text, know what a valve looks like, know where it is located on that specific 3D model of the machine, and understand the physical action of tightening it?
It's a great question.
There just has to be a massive gap between reading a sentence and coding spatial physics.
And that gap is bridged by what the developers call primitives.
Primitives.
Yeah, the AI analyzes the geometry of the 3D objects and maps out the necessary interactions using a library of 60 foundational primitives. Think of a primitive as the digital DNA of an action.
Oh, like a building block.
Exactly. It's a foundational building block, like the physics of a hinge opening, the rule of gravity for a dropped wrench, or the rotational physics of tightening a valve. The AI reads the manual, understands the intent, looks at the geometry of the CAD file, and applies the correct primitive to that specific part of the engine.
Wow.
Yeah, it essentially builds the interactive skeleton of the training module on its own, based purely on the text.
That is fascinating. So instead of hiring an architect, a carpenter, and an electrician to build a house from scratch, you are basically handing a script to a magic director who instantly builds the stage, sets the lighting, and programs the physics of the props based entirely on your stage directions.
That is an excellent way to conceptualize it.
Yeah.
And if the mechanic wants to change something, they use a feature called conversational scene authoring. This completely eliminates the need for technical editing tools.
So just talk to it.
Exactly. The mechanic refines the simulation simply by talking to the AI using natural language commands.
The examples in the text really bring this to life. You can just tell the system add a high-pitched warning sound when this panel opens, or dim the ambient lighting to simulate a power failure.
It's so intuitive.
It is, because if you have ever tried to use professional video editing or game engine software, you know that doing something simple like adding a sound effect requires navigating a maze of drop-down menus, importing audio files, adjusting waveforms, and linking triggers.
Oh, yeah, it's a nightmare.
But with Genesis 3.0, you just tell the AI what you want in plain English, and the platform executes the code in the background.
And by doing that, the platform completely removes what we call the translation layer.
Yeah.
In the old system, the mechanic had to explain the procedure to an instructional designer.
Right.
Then the designer wrote a script and explained it to a software developer. The developer explained the visual needs to a 3D artist. Every single step of that translation layer introduces delays, costs, and just the potential for miscommunication. Now, the 30-year veteran mechanic just speaks their knowledge directly into the software.
The knowledge goes straight from the expert's brain into the simulation. But, as incredible as it is to build a beautiful, accurate environment, that is only half the battle. Because an environment is totally useless if it is trapped on a specialized $3,000 headset locked in the IT department's closet. The true test is how the trainee actually gets inside it.
Which naturally moves us to the second major phase of this 11-step workflow, the play phase. That covers steps 8 through 11. Now that our seasoned mechanic has built this immersive simulation, how does the terrified new hire on their first day actually experience it?
Right.
The most critical element for true enterprise scale here is the multi-device deployment.
I cannot emphasize enough how big of a deal this is for anyone who has ever worked in tech. The white paper states that once the module is finalized, it is deployed instantaneously across multiple platforms with absolutely zero porting required.
Zero, which is unheard of.
For anyone who isn't deep into software development, porting is usually a nightmare. Taking a dense 3D program built for a high-end VR headset and making it run smoothly on a standard corporate laptop or mobile phone usually requires a whole team of developers rebuilding huge chunks of the code.
Yeah, compressing textures, changing lighting engines.
Exactly.
Porting is often budgeted and scheduled as an entirely separate standalone project. It is incredibly time-consuming.
But Genesis 3.0 pushes the exact same module everywhere at once. Desktop, mobile phone, augmented reality glasses, virtual reality headsets. Think about what that actually means for your daily life as a learner.
It changes everything.
You could be assigned a highly complex, potentially dangerous operational task, and you can pull out your smartphone on the train during your morning commute and physically tap your screen to practice the sequence of turning the valves. The accessibility completely changes the dynamic of when and where learning happens.
It does. And furthermore, the experience isn't just a static 360-degree video on your phone. The play phase incorporates specific, multimodal interactions designed to keep the learner actively engaged.
What kind of interactions?
Well, the text highlights several proprietary tools built into the system, such as the heygen AI agent, Mixamo avatars, virtual hands, and a drone fly-through feature.
Okay, those names sound incredibly futuristic, but let's break down what they actually do for the learner so we aren't just tossing around tech jargon.
Sure. So heygen is an AI video generation technology that creates incredibly realistic, AI-driven human guides. Instead of reading a text box pop up on screen, you have a lifelike virtual instructor actually speaking to you with perfectly synced lip movements and natural expressions.
Oh, wow.
Then there's Mixamo, which is a vast library of highly detailed fluid character animations. So when these avatars walk across the factory floor or demonstrate how to lift a heavy box, they use fluid, lifelike skeletal movements.
Right.
They look like real human beings demonstrating a task, rather than looking like stiff, awkward robots from a 1990s video game.
And the cognitive science behind why this matters is huge. We're talking about reducing cognitive load. When you read a text manual, your brain has to work incredibly hard to translate 2D words into a 3D mental map of a machine you've barely even seen. But when you use virtual hands to physically reach out and grab a lever in VR, or you watch an avatar perform the action fluidly, you are completely bypassing that mental translation. You are directly building muscle memory. You're experiencing spatial learning, which sticks in the brain far longer than passive reading.
And the tools accommodate both guided and practice-based learning. The drone fly-through, for instance, can give a new hire a sweeping bird's-eye view of a massive facility layout, pointing out emergency exits and hazardous zones before they ever step foot inside the physical building.
That's so smart.
It really transforms a dry reading assignment into an active, spatial, and memorable experience.
I am fully on board with the cognitive benefits of spatial learning, but I have to bring us back to reality for a moment.
Uh-oh. Okay.
Well, because while fluid avatars and drone fly-throughs sound amazing and incredibly entertaining, we need to talk about the stakes. In high-stakes enterprise environments like safety protocols on that offshore oil rig or maintenance on a commercial airliner, how does EON Reality ensure this isn't just an entertaining video game?
Right. Safety is paramount.
Because if an AI hallucinates an extra finger in a digital painting, it's funny. If an AI hallucinates the location of a safety valve on an oxygen tank, it is lethal. So how do they ensure this is a rigorous, trustworthy tool?
That is the critical threshold for any enterprise technology, and the source material addresses it directly. The documents outline a core philosophy from EON AI Ventures generic consumer AI tools might deliver 80% quality.
Right.
If you're using ChatGPT to help write an email or brainstorm marketing ideas, 80% accuracy is perfectly fine. You can just edit the rest yourself. But high-stakes industrial operations require 100% precision. There is no margin for error when training someone to handle hazardous materials.
Exactly. An 80% success rate on an oil rig is a catastrophe. So how do they enforce that 100% precision when the mechanic is just talking to the AI in plain English?
Under the hood, Genesis 3.0 utilizes advanced WebXR rendering and deep vision AI analysis to ensure exactness. The Vision AI essentially acts as a strict physics referee. It constantly checks the 3D spatial environment against the real-world physical constraints of the imported CAD file. It ensures that the geometry is rigidly enforced.
Oh, I see.
So your digital hand cannot accidentally phase through a virtual engine block, and the AI cannot invent a valve that doesn't exist on the engineering blueprint. The subject matter expert gives the commands, but the AI rigorously enforces the rules of physical reality to ensure the simulation perfectly mirrors the actual equipment.
That makes a lot of sense. And the platform is rigorously tracking the human results, too. The white paper highlights a measure and improve module. It doesn't just give you a simple pass or fail grade at the very end of the simulation. The platform tracks your step-based scoring in real time.
Yeah.
Every hesitation, every incorrect tool selection is logged to an instructor dashboard. And interestingly, it actually leans into gamification to drive the results, using XP points, digital badges, and leaderboards.
Which is funny because using terms like XP points or leaderboards might seem really counterintuitive when we're discussing serious enterprise safety protocols.
It definitely feels a bit strange at first,
Yeah.
but the psychology of gamification for knowledge retention is undeniable.
It really works.
If you tell a group of competitive trainees that they are on a leaderboard against their shift mates for the fastest, safest, most precise completion of a complex maintenance check, human nature totally takes over.
Oh, completely.
They are going to log into that simulation on their phone 5 extra times over the weekend just to get their score up and beat their coworker. And that is pure repetition. That is deeply ingrained muscle memory being built in a totally safe, risk-free digital environment.
Which perfectly synthesizes a powerful quote from Dan Lajerskar, the chairman of EON AI Ventures that was included in the announcement. He explicitly calls Genesis 3.0 a paradigm shift. And when you assemble all the mechanics we've just discussed, the AI parsing the text, the conversational authoring, the instant deployment, the physics enforcement, it becomes really clear that this is not simply about a company saving $200,000 on software developers.
Right.
The cost savings are a nice benefit, but they are not the core transformation.
The core transformation is about the speed of human capability. It is about dramatically shortening the time to competency for a worker. It means taking that terrified new hire on the oil rig and giving them the spatial awareness, the muscle memory, and the hazard recognition of a 10-year veteran in a tiny fraction of the time.
Absolutely.
It is fundamentally about enhancing workplace safety and operational readiness in an era where the global economy is moving far too fast for a 300-page paper manual to keep up.
It democratizes the creation of elite-level training, unlocking the knowledge that has been trapped in the minds of the experts.
So, let's summarize the journey we've taken today. We started by looking at a broken pipeline, a massive bottleneck, where creating a single immersive training module took 12 weeks, cost a fortune, and starved the workforce of the high-quality training they desperately needed.
The sports cars were parked in the lot, and there were no roads to drive them on.
Exactly. And we discovered how Genesis 3.0 is attempting to pave those roads almost instantly. By utilizing an 11-step conversational AI workflow, they are putting the power of XR creation directly into the hands of the people who actually know the job. They are letting the AI handle the heavy lifting of 3D rendering and physics coding, ensuring 100% exactness, and instantly deploying that critical knowledge to any screen a worker happens to have in their pocket.
It is a remarkable leap forward, but, you know, it also raises a profound question, a final concept for you to really mull over.
Okay, let's hear it.
Genesis 3.0 effectively removes the technical barrier to creating elite training. But if the knowledge of an expert can be perfectly digitized, and anyone can instantly generate perfect immersive training environments just by talking to an AI, what happens to our traditional definition of a seasoned veteran?
Oh, that is a fascinating thread to pull.
Right. Think about the implications. Imagine a 20-year-old kid straight out of a technical school. Because of this technology, they have been able to run a highly specific, catastrophic engine failure simulation 500 times in perfect virtual reality.
Right.
They have built the muscle memory to fix it blindfolded. Now compare them to a 50-year-old mechanic who has been on the real job for 30 years, but has only ever encountered that specific rare engine failure once in their career.
Wow.
When an AI-trained novice can experience years' worth of high-stakes, 100% precise scenarios before ever stepping onto a real job site, will traditional years-long hands-on experience still hold the same supreme value? Or will the simulation become the new standard of reality?
If the simulation is mathematically perfect and the muscle memory is real, maybe the roads we are building don't even need physical cars anymore. The definition of experience itself is changing. That is definitely something to chew on. Thanks for joining us on this deep dive, and we'll catch you next time.